Hi everyone, I'm Ron from Business Hong Kong. Welcome to Business Hong Kong YouTube channel. This is our first MicroPython tutorial for W55MH32, and today's topic will be the GPIOs. If you wanted to know more about how to install MicroPython for W55MH32, you could refer to our short videos. The links will be in the description below. Okay, GPIOs. For understanding the GPIOs, we need to show you the pin descriptions. So if you want to know about the pin description of GPIO for W55MH32, you need to go to dots.w5500.com. In dots.w5500.com, scroll down to the bottom of the page. It has the pin description specifically for W55MH32 LEVB. The pins showing green are the GPIO pins. For the others, I will mention in the future videos. Today we will specific to discuss about PD14 and PG6. These two pins has been directly connected to the inboard LED and the inboard button. That will be located in here. The PD14 has been connected to the LED, and for the button has been connected to the PG6. If you wanted to know more about the hardware design of this board, you could visit .biznet.io. In .biznet.io, go to Chips, MCU, W55MH32. It has the basic information related to the W55MH32. Scroll down to Hardware Resources, and you could find the reference schematic. This reference schematic is the W55MH32 LEVB reference schematic. Go to page 2. It has the related information. For PD14 has been connected to the LED light, and the PG6 has been connected to the button. Okay, let's try to do some demo. So for running MicroPython in W55MH32, I will use Thorny IDE. Thorny IDE is specific for Python or MicroPython programming. So first thing, we need to call the related module or library for pins. And pins is actually in the machine module. So if you want to call the pin, you need to do is from machine import pin. So right now, let's try to turn on the LED light. So LED needs to be equal to pin. I call the pin module, and then I select the related pin PD14, and I will set to pin out. That means the pin has been set to pin output. So right now I could change the values of the LED. So I need to set the value is equal to 0. What does it mean? So in this case, the LED value has required to set to a lower level signal to turn the LED on. This is the design of the board. So let's test it right now. If I press the run button, you could see the LED has turned on. If I change it to a high level signal, that means I change it to 1. I run the script again, the LED will be turned off. Okay, right now we could try to set a button to control the LED. So if I want to, I need to create a button value first. So button equal to pin PG6 and then pin in to set it as an input. After that, I need to create a continuously loop to check the button status. So while true. So I have created a continuously loop. Right now I need to check the button status every time. So if button value is equal to 0. Why 0? Because in this design, the button, when the button is pressed, it will generate a low level signal. So if the button value is equal to 0, I need to set the LED light to turn on. So it needs to be the LED value changed to 0 as well. If that's not the case, that means it determines the button value has been changed to 1. That means in the release state. So LED value is 1. So let's try to run the script. So as you could see, when the button is released, the LED didn't turn on. But if I press the button, it turns on, and I could test it frequently because it's actually is in the continuous while loop. So this is the most simple way to control the GPIOs on controlling the LED board and the button. In the future, we will create more kinds of MicroPython tutorials based on W55MH32. Stay tuned. Thank you for watching.